Hello learners, back again with another video. In today's video we will discuss about O2 molecule, O2 negative ion and O2 2 negative. Why we are taking these ions? O2 is a molecule here. This one is superoxide ion and this one is peroxide ion. We will tell about the bond order of these ions and molecule and their magnetic behavior, whether they are paramagnetic or diamagnetic. Fine, we have done linear combination of atomic orbital theory. According to linear combination of atomic orbitals, when atomic orbitals combine, the resulting formation of molecular orbitals. The molecular orbitals formed were bonding orbital and anti-bonding molecular orbitals. Okay, we are not taking the theory of linear combination of atomic orbitals. We'll discuss only the bond order and magnetic behavior of these ions. Fine, according to spectroscopic data, what we got that the molecules, they are divided into two parts. We can say there are heavier elements and one are lighter one. The elements which are heavier, they have some configuration according to spectroscopic data, that is 1s2 sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, comma, these are different atomic orbitals. And then in case of oxygen, we are having sigma 2px, pi 2py, pi 2pz, and then pi star 2py, pi star 2pz, and sigma star 2px. What is this? This is the electronic configuration of molecular orbitals. When atomic orbitals are combining, one atomic orbital is combining with the another atomic orbital and they are resulting in formation of a molecule, then we are having such type of electronic configuration of a molecule, not of a single element atom. Okay, so what happens here? This we have got the electronic configuration through spectroscopic data on the basis of their energy. Increasing energy of atomic orbitals, or we can say anti-bonding molecular orbitals. Fine, this is for the elements which are heavier one. And in case of lighter elements, the configuration will be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then we will have pi 2py, pi 2pz, and then sigma 2px. After this, we'll have sigma star 2px and then pi star 2py and pi star 2pz. In the same way, increasing energy order. Okay, heavier elements we are talking about here are oxygen. Lighter elements here we are talking about here boron, carbon and nitrogen. That means if we have to write the electronic configuration of O2 molecule, we will use this electronic configuration. But if we are writing the electronic configuration of boron, carbon and nitrogen, we will use electronic configuration of this. We will be talking about oxygen and their ions, not about the boron, carbon and nitrogen. So let's talk about the electronic configuration, their bond order and magnetic behavior of oxygen and their ions, oxygen molecule and their ions. Okay, let's see. First we are having O2 molecule. O2 molecule, oxygen has number of electrons 2 plus 6, that is equal to 8 electrons. Okay, so total O2 molecule will be having 16 electrons. So first we will write the electronic configuration, that will be sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2. Okay, right? Then according to that energy of the orbitals, we are having sigma 2px 2px2, and then we are having pi 2py pi 2pz. Okay, and then y star 2py pi star 2pz. We are having here 16 electrons, so 2 will go here, 2 will go here, and sigma star 2p x1 is left. So we'll be having 1 1. Okay, 2 4 6 8 10 11 12 13 14 15 and 16, total 16 electron. Pairing of electron will not take place until each orbital is singly occupied. That rule is followed here. Now we will see bond order. Formula of bond order is number of electrons in bonding orbital minus number of electrons in anti-bonding orbitals, and that is divided by 2. So here we are having bonding orbital 2 to 4 to 6 to 8 and to 10. So we are having bonding orbital 10. Okay, and anti-bonding 2, 4, 5 and 6. 10 minus 6 divided by 2. 4 divided by 2. Here we are having 2 bond order. That means oxygen and oxygen carries double bond according to bond order. Second thing, whether it is diamagnetic or paramagnetic. We know paramagnetic substances are those which are having unpaired electron. Unpaired electron. And those which doesn't carry unpaired electron, paired, fully paired, full orbital, or we can say paired orbitals, then those are called diamagnetic. So here we are having 2 unpaired electrons. So that's why O2 molecule is paramagnetic in nature. Okay, this is about O2. Next we'll talk about O2 negative. I am just making few changes over here. Here we are having O2 negative. When we are saying negative, that means there is an addition of electron. So here we are having number of electrons 17. 17 number of electrons. We doesn't know whether it is paramagnetic or diamagnetic. Let's check it out. So configuration will remain same as we are talking about oxygen, but here as one electron is adding, so we are just seeing where it will be going. We know the rule, the pairing of electron will not take place until each orbital is singly occupied. They are already singly occupied, then addition of electron will take place over here and become paired up. So here there will be 2. Fine. So now see, we were having 10 bonding orbitals and now we are having 2, 4, 6, 7, 2, 2, 4, 6 and 7. 7 anti-bonding orbitals divided by 2. So here we will be having 3 by 2, that means 1.5. That will be the bond order of O2 negative, which is also known as superoxide ion, KO2, potassium superoxide, carrying superoxide ion. Fine. So here we are having bond order 1.5, that means neither single bond, neither double bond. Okay. So this is about the bond order. Now we'll see about the magnetic behavior. Here we are having one unpaired electron. We are checking here whether there is unpaired electron or not. Yes, there is an unpaired electron here. We are having one unpaired electron, that's why it is also paramagnetic in nature. Okay. Now third we are talking about O2 negative. So here we are making changes O2 negative, which is known as peroxide ion, and here we are having one more electron. So number of electron are total. This is one oxygen atom. We are talking about 2, so that's why I am taking the 18 electron. So here we are having number of electrons 18. We doesn't know whether it is paramagnetic or diamagnetic. Let's check it out. And here Na2O2, sodium peroxide, carries this ion. Okay, now we are seeing one more addition. So one is left here. So we are just pairing it up. So instead of 7 here, now we are having number of anti-bonding orbital 8. So that means we are having bond order is equal to 1. That means this oxygen carries single bond according to bond order. Okay. Now let's check it out whether it is paramagnetic or diamagnetic. We are saying that if all the orbitals are paired, there is no unpaired electron. Check it out, 2, 2, 2, 2, 2, fully paired, fully paired, fully paired. As the capacity carries, one orbital carries 2 electron only. So all the orbitals are paired. That means this one is diamagnetic in nature. Okay. So we have got the magnetic behavior and bond order of different ions of oxygen. Let's check it out. We'll take a little summary here. What is we have talked about O2 negative and O2 negative. O2 was having bond order 2. I'm writing here a bond order 2, 1.5, 1. Magnetic behavior. Unpaired electron was there, it was paramagnetic. Unpaired electron was there, it was also paramagnetic. And this one is diamagnetic due to paired electron. 2 unpaired electron was there, 2 unpaired electron, 1 unpaired electron was there. This is all about the bond order and magnetic behavior of oxygen and their ions, superoxide and peroxide. Next we'll talk about different one. Don't forget to like and subscribe it. Thank you for watching the video. Thank you.